All right, so today's video tutorial is just a quick little video on some concepts in section 7.5, long division of polynomials. So our goal is to be able to use long division to divide polynomials. And then once we understand how to use long division, we want to be able to decide if one polynomial is a factor of another. So we're going to start with just the general idea of what we're doing with dividing polynomials. So I have right here set up, if I were to take x plus 2 multiplied by 3x squared minus 4x plus 5, that would result in the polynomial 3x cubed plus 2x squared minus 3x plus 10. So what we're going to do is we're going to actually go backwards with that, right? So we're going to take the polynomial 3x cubed plus 2x squared minus 3x plus 10, and we're going to divide it by the polynomial x plus 2, for example. Now, we would expect that we should get 3x squared minus 4x plus 5. Right? Because if this times this is this, then this divided by this should be that. All right, so let's try it out. So when we set up long division, we're going to set up long division very similar to how we would divide with just numbers, right? So when we set up long division for numbers, I think you did this in like 3rd grade. If I were to do like 226 divided by 3, okay? So 226 divided by 3, we set it up by taking 226, put it under the divisor, and then 3 goes on the outside. So then we say 3 goes into 22 how many times without going over? And so 3 goes into 22 7 times without going over. And then what we do is we multiply that number on top by whatever we're dividing by, and we subtract that value. So 7 times 3 is 21, and we subtract that. So we get 1, carry the 6, we get 16. And then we say, okay, 3 goes into 16 5 times without going over, and then we multiply again. So 5 times the 3 now, and that's minus 15. And here we get a remainder of 1. And I'm not sure if you guys remember what you did with that remainder, but in olden school days, what we would do with that remainder, sometimes we just write remainder 1, right? But we're going to actually go ahead and write it as a fraction of the whole that we divided by. So we have left over 1, and we divided by 3. So 226 divided by 3 is 75 and 1/3. And we're going to transfer that into our knowledge of dividing polynomials. So what I want to do is I want to take this 3x cubed plus 2x squared minus 3x plus 10, and I want to divide it by x plus 2. So I'm going to start by actually just looking at the first term in the polynomial and trying to fit it into the first term of whatever's underneath my divisor. So x fits into 3x cubed how many times without going over? Okay, so x times 3x squared gives me 3x cubed. So my answer is going to be 3x squared goes on top. I'll do a little side work here because I can't, I'm multiplying a monomial by a binomial, so I want to make sure I know that I got this right. So I'm going to take 3x squared times that x plus 2 that's on the outside. I get 3x cubed plus 6x squared. And now, if we remember, I want to subtract that quantity. Okay, so I'm going to do minus 3x cubed plus 6x squared. And then I get 3x cubed minus 3x cubed is 0. 2x squared minus 6x squared is negative 4x squared. And then I bring down the negative 3x and the positive 10. And I start the process all over again. So this time I'm saying x goes into negative 4x squared how many times? So x times negative 4x would give me negative 4x squared. So negative 4x multiplied by x plus 2 gives me negative 4x squared minus 8x. And then I want to again subtract that quantity. So I'm going to subtract the negative 4x squared minus 8x. And negative 4x squared minus a negative 4x squared, that's really like saying plus, so that's 0. Negative 3x minus negative 8x is like saying negative 3x plus 8x, so that's 5x. And then bring down the 10. And then last but not least, let's fit that x into 5x. So x times 5 will give me the 5x. So then 5 times x plus 2 is the quantity 5x plus 10. And I subtract the quantity 5x plus 10 from 5x plus 10. That gives me 0. I expected to get a remainder of 0 because if we look back up here, we knew that these two actually multiplied to get that polynomial. So I get a remainder of 0. Now I could write plus 0 over x plus 2, but I really don't need to. I can just write my polynomial as 3x squared minus 4x plus 5. So one thing I want to point out is that when I get a remainder of 0, that means that that polynomial divided nicely by the other polynomial. And we have a special name for that, right? So when we think about our 2 learning targets today, we wanted to be able to decide if one polynomial was a factor of the other polynomial. And in order to be a factor, we think about this, is 8 a factor of 64? In order to decide that, we ask, does it divide nicely? And since 64 divided by 8 gives us 8, okay, it divides into to be a whole number. We have no remainders, so the answer is yes, right? If we asked, is 3 a factor of 20, the answer would be no, because when we divide 20 by 3, right, we end up getting a remainder of 2. And so it's not a factor because we get a remainder. So in this case, what I'm trying to get at is x plus 2 would be considered a factor of 3x cubed plus 2x squared minus 3x plus 10 because it divides nicely. I get a remainder of 0. Okay, so let's transfer that to the question, is x minus 2 a factor of 3x cubed minus 2x squared minus 13x plus 14? And so to answer that question, we're going to have to divide the polynomials. And so we're going to start by trying to put x into 3x cubed. And so that goes into 3x cubed, 3x squared times. Doing a little side work over here, I made a really long bar. 3x squared times x minus 2 is 3x cubed minus 6x squared. And I'm going to subtract that. So minus 3x cubed minus 6x squared. That gives me 0, and negative 2 minus a negative 6 is a positive 4x squared. Bring down the negative 13x, bring down the positive 14. Then I'm asking myself, how many times does x go into 4x squared? X times 4x is 4x squared. So 4x times the quantity x minus 2 is 4x squared minus 8x. I want to subtract that quantity, 4x squared minus 8x. And then I get negative 13 minus negative 8 is negative 5x plus 14. And then one more time, I'm going to ask myself, does x go into negative 5x, negative 5 times? So negative 5 times x minus 2 gives me negative 5x plus 10. And so I'm going to subtract the quantity negative 5x plus 10. Negative 5 minus a negative 5 is 0. 14 minus 10 is 4. And so at this point, I kind of stop and I say x can no longer go into 4. In order to x multiplied by another polynomial would not give me 4. I'd have to multiply by something over divided by x. So I stop there, and I have a remainder of 4. So now I just write plus 4 divided by x minus 2, right? So I take whatever my remainder is, and I put it over whatever I divided by, just like with long division. And so when I divide 3x cubed minus 2x squared minus 13x plus 14 by x minus 2, this is the result. But the question was, is x minus 2 a factor? So I didn't want to just know the result. I wanted to actually answer this question. To answer the question, I'm going to say no, because we have a remainder, right? So it doesn't divide nicely. So it's not a factor. All right. Last one. We're going to take, oh, I didn't want to rewrite that there. Shoot, I gave it away. Mom. Okay, so if I take x cubed plus 8 and I'm multiplying that by the quantity 2x plus 1 raised to the negative first power, sometimes that tricks people. But remember that raising to that negative first power is the same thing as dividing by that quantity. So this is the equivalent of x cubed plus 8 divided by the quantity 2 plus x. Now, I wrote this like this, and I want to talk about what would happen if I didn't, okay? So I'm going to just try and divide this the way it is. So I'm going to do 2 plus x is what I'm dividing by, and x cubed plus 8 is underneath my divisor. So I'm going to start, and I'm going to say, let's fit 2 into x cubed. So what do I multiply 2 by to get x cubed? Well, I'd multiply by 1/2 x cubed. And if I take 1/2 x cubed, and I multiply it by 2 plus x, I'm going to get 1x cubed plus 1/2 x to the 4th. And so I want to subtract x cubed plus 1/2 x to the 4th. And you should notice something right away. The issue is I'm actually taking a polynomial and I'm subtracting a bigger polynomial. So I actually turn this into a bigger polynomial than I started with. And that's really not what I want to do. I want to make sure that whatever I'm subtracting is a smaller polynomial. And by smaller, I mean the degree, right? So this is x to the 4th. That's a higher degree than x cubed. So the error that occurred here was that my polynomials didn't start in standard form, right? So standard form means that I organize both my numerator and my denominator in order from highest to lowest degree. So the numerator's fine. The denominator, I need to switch the order around to be x plus 2. Okay, so I want to, before I divide, make sure that I put all polynomials, whether or not it's the quotient or the divisor, put all polynomials in standard form. Okay, so now I'm going to restart this, and I'm going to make this x plus 2. And this is going to look a little different here, so it's not going to be 1/2 x cubed anymore. Let me erase, for the love of goodness sake. So I'm going to fit x into x cubed. That's x squared. And now I'm going to do my little side work. X squared times x plus 2. That gives me x cubed plus 2x squared. So now I want to subtract this quantity. I want to minus x cubed plus 2x squared. And when I go to subtract these, I can tell really quick because I still have these, the variables in my problem, right? I can see x cubed minus x cubed is gone, but now I have 8 minus 2x squared. And those aren't like terms. So we can write 8 minus 2x squared and then reflip this order around. Or we can start the problem a little bit differently, and I recommend that you do this when you're doing long division because it'll transfer nicely into synthetic division. We can start the problem by using what we call placeholders for any missing degree. And by missing degrees, I mean if I start with my highest degree polynomial is 3, I should have all the degrees accounted for that are below 3, right? So x cubed, I should have x squared accounted for, I should have x accounted for, and then the constant accounted for. Okay, so what I'm going to do is take x cubed plus 8, and I'm going to go ahead and expand it to be x cubed plus 0x squared plus 0x plus 8, so that all of my placeholders are accounted for. So instead of writing x cubed plus 8, I'm going to write plus 0x squared plus 0x plus 8. So I'm not missing that x squared term or that x term. And now when I do this subtraction, it makes it a little bit easier. So it becomes 0x squared minus 2x squared is negative 2x squared. And then I can bring down the 0x and bring down the 8. And then I can keep the process going. It'll go a little smoother from here on out. So x fits into negative 2x squared, negative 2x times. I'm going to do my little side work over here. Negative 2x times x plus 2 is negative 2x squared minus 4x. I want to subtract that quantity, negative 2x squared minus 4x. So that'll give me 0. 0 minus negative 4x is positive 4x plus 8. And last but not least, x goes into 4x 4 times without going over. 4 times x plus 2 is 4x plus 8. And so I'm going to subtract the quantity 4x plus 8. I get 0. So when I divide, the answer to x cubed plus 2x plus x cubed plus 8 multiplied by the quantity 2 plus x to the negative first power is the polynomial x squared minus 2x plus 4. All right, that's it. That's all I got for you. Feel free to practice some long division in section 7.5.